Hi, my name is Taminarsi. Today I'm going to present about metrological traceability and calibration in laboratory. First, I want to give definition of certain terms. The definition of metrological traceability is a property of a measurement result whereby the result can be related to a reference through a documented unbroken chain of calibration, each contributing to the measurement uncertainty. Second is I'm going to give the meaning of calibrations. Is a documented comparison of the measurement device to be calibrated against a traceable reference standard or device. The reference standard may also refer to as a calibrated, should be more accurate than the device to be calibrated and should also be calibrated traceably. For me, the calibration does not include adjustment or trimming. Next, I will give example of traceability in calibration. For example, you may calibrate your process measurement instrument with a portable process calibrator. The portable process calibrator you use should be calibrated using a more accurate reference calibrator. The reference calibrator should be calibrated with an even higher level standard or sent out to an aggregated or national calibration center for calibration. Next, what is calibration uncertainty? Is a property of a measurement result that defines the range of proper values of the measurement. Uncertainty means the amount of doubt in a calibration process. So it tells how good the calibration process was. Uncertainty can caused by the various sources such as the device under test, the reference standard, calibration method, or environmental condition. If the uncertainty of the calibration process is larger than the accuracy of tolerance level of the device under calibration, then calibration does not make much sense. This picture shows that the metrological traceability in calibration in plants can be presented as a pyramid. The pyramid shows how the different levels in the traceability are located, as all your process instruments show are located in the lowest level. Their traceability is dependent on all the levels above. So, calibration metrological traceability chain in practice. In laboratory, first, process instruments such as transmitters that are calibrated regularly using process calibrated or similar measurement standard. The process calibrator is typically sent out to an external calibration laboratory for calibration, assuming it is the highest level reference standard. Alternatively, the process calibrated may also be calibrated internally using a higher level reference standard. The highest level reference standard are sent out to an external calibration laboratory, preferably an aggregated one, to be calibrated. The external calibration laboratory will calibrate their reference to ensure traceability to national calibration laboratory or similar. The National Calibration Laboratory work with international level laboratories and make international comparison with each other, ensuring that their calibration are on the same level. The international level laboratory base their measurement on international comparison, international definitions, and realization of the international system of units. This picture shows the metrological traceability in calibration can be presented as a chain. The higher go in the chain, the smaller the uncertainty. How a process measurement take made traceable up to an international level through an unbroken chain of measurement. So when can you claim that your measurement is traceable? First, timely calibrations. The calibration of any measurement device only remains barely for a state period of the time. Therefore, the traceability expires when the calibration expired. So every step needs to be documented. Means the calibration results are documented in the calibration certificate, but also that the calibration procedure is done according to a written procedure according to the company quality system. It is very clear that a calibration without a calibration certificate is not a proper calibration, and certainly not a traceable calibration. It is good to remember that if the calibration is done without documented procedure, if an environment without a quality system, the calibration is not reliable and cannot be proved to be traceable. Third, every step need to include measurement uncertainty. It's also very important that every calibration step in the traceability chain has been related measurement uncertainty documented. If the uncertainty information is missing from the calibration, you can't claim it is traceable. The main reason because without knowing the documenting the uncertainty, you could calibrate an accurate measurement equipment with one the is less accurate, or that the calibration procedure caused such a big uncertainty that its calibration is neither good or traceable. Next, we go for the internal calibration. It also uh, can transfer the traceability from one reference to the next one, or to the process instruments, even multiple times in multiple levels. The basic requirements such as calibration results are documented in certificate. There are sufficient procedure on how to perform the calibration. There is a quality system, and also the training, the competence of workers are adequate and documented in records. The last is the uncertainty of the calibration is known and documented. So what means of external calibrations? Is accredited or not? Using an accredited calibration laboratory is highly recommended, because if you use an non-accredited laboratory, you must audit yourself that the laboratory is traceable. For example, traceability of the laboratory is documented, is a quality system and proper procedure are in working order, competence of workers are adequate, uncertainty of the calibration is properly calculated, and the last is uncertainty of the calibration is suitable for your own use. So in a calibration procedure, the test accuracy ratio, TAR, is the ratio of the accuracy tolerance of the unit under calibration to the accuracy tolerance of the calibration standard used, while the test uncertainty ratio, TUR, is the ratio of the accuracy tolerance of the unit under calibration to the uncertainty of the calibration standard used. We commonly hear about using a TAR ratio of 4 to 1, which means that the reference standard is 4 times more accurate than the device under test DUT. The accuracy specifications of the reference standard should be 4 times better or smaller than the one of DUT. So why is a pass and fail calibrations? Most often, when you calibrate an instrument, there is a tolerance limit, acceptance limits set in advance for the calibration. This is the maximum permitted error for the calibration. If the error means the difference between DUT and reference at any calibrated point is larger than the tolerance limit, the calibration will be considered as failed. In the case of failed calibration, you should take corrective action to make the calibration pass. Typically, you will adjust the DUT until it is accurate enough. Thank you.